Here we'll be taking a look at one of the commonest methods of drawing an ellipse, or perhaps the best known method of drawing an ellipse, and that is using two pins and a string. This is how the method works. On a sheet of paper you mount two pins and then tie a string between them. Of course it should be long enough to remain loose like this. Then you engage a pencil in that string to keep it taut and then move it around. The curve that gets traced is an ellipse. But there are a few things that we need to figure out before we start with this. Number one, an ellipse is typically never specified in terms of the distance between two pins and a piece of string. It will be specified more often in terms of, say, its major and minor axis. So we have to figure out the relationship between the major and minor axis lengths and this pin and string business. To our aid is one fact that each of this pin represents the focus of an ellipse, and that will help us come up with some construction. So let us start with this schematic ellipse here. So this is the major axis, AC is the minor axis, F1 and F2 are the foci, and O is the center. Then let us consider the position of our pencil, say at some arbitrary point P like this, and then this yellow line will represent the string. So its length will be equal to F1P plus P F2. That is the total length of the string. Now imagine the pencil has moved to this vertex at the end of the major axis, vertex B. In that case the string will be lying along F1B and then it will double back to B F2. Let us say this overlapping length is cut and laid down over here, and it will lay here from F1 to D by symmetry, and therefore you would realize that the length of the string is exactly equal to the length of the major axis. So we have solved the first part of the riddle. The length of the string is nothing but the major axis. Now to the second part, how to figure out the position of the two pins or the two foci. For that we are going to make use of the fact that the length of the string is equal to major axis. So when the pencil is at, say, A, the vertex at the end of the minor axis, half the string, which is half the length of the major axis, will be equal to F1A. So let us draw a circle with major axis as the diameter and then move that circle so that its center is now located at A. In this position the circle will intersect the major axis at the two foci, F1 and F2. So this is a method of finding the two foci. Now that we have all the essential information for placing the ellipse, like the distance between the two pins and the length of the string, let us follow this action link and go to the physical model. Here. So here are the two pins, only we have made a little difference to make it more convenient. Okay. So look at this movement of the pencil. The blue is the string. When it comes to this position, it is about to cross over from one side of the major axis to the other, and here a string can get stuck. So instead of using a single piece of string tied at two ends to the two pins, we are going to use a loop. So whatever length of string that we have calculated, add to it the distance between the two foci and make a loop out of it, and then your ellipse will be more conveniently drawn like this. By the way, I have a great memory to share with you regarding this method of drawing an ellipse. When I showed this to a second grader, she asked me a question that threw me back for a few minutes. She said, what will happen if we use 3 pins instead of 2? So just imagine one more pin somewhere over here and try to figure out what kind of curve we would get. I'll be posting the answer, maybe an animation, in a few weeks.